You're listening to India Bio Speaks, your one-stop resource for science, news and careers. Welcome everybody to our next episode on crafting your career in science. Continuing with the informational interview series, we're talking today with Minhaj Sirajudin, Assistant Investigator from inStem Bangalore. Thank you for joining us, Minhaj.
Thank you very much for having me here. Look forward to your questions.
Well, Minhaj has followed the much coveted career trajectory from moving from being a PhD student at Max Planck in Germany to a postdoc at UC San Francisco in the US, receiving the Wellcome Trust DBT India Alliance Intermediate Fellowship and the EMBO Young Investigator Program Awards. He now runs his independent laboratory, the Cytoskeletal Lab, at inStem Bangalore. Let's together today learn about his journey into academic research. Minhaj, can you describe your career journey so far and tell us when and how did you realize that research was your calling?
I cannot trace back a single event or time point where it kind of told me that research is my calling. But top of my head, I can tell a couple of instances which actually were influential in deciding which career path I want to take. This was during my master's. The human genome was first sequenced, and that motivated me to look more into protein structures and understand how this might be beneficial for biomedical research and health problems. After that, my master's, I also did a project assistant or a JRF in a lab with Professor Raghavan Varadarajan at MBU and IISc, and I was really gravitated to the idea of working in a research lab because I felt that I was very comfortable in that scenario, and I really liked the research conditions. So I think those two events actually pushed me more into research, I would say.
Minhaj, can you tell us what is the current focus of your laboratory?
Currently, we are focusing on understanding how biological motility works. It can be anything from muscle contraction to heartbeat or sperm motility or microscopic particles which are moving inside in the cell. So anything which is moving, we are interested in studying. Also, there is a physiological relevance to this because if you see, most of the human diseases have some relation to something which is not motile or motile actually. So we are also very much interested in understanding how these motility pathways are being dysfunctional or affected during pathological conditions. For example, cardiomyopathy is a muscle heart disease which can be inherited. The mutations can be inherited in the families, and these mutations can be the genes which are involved in muscle contraction, for example. So bottom line is that the biological motility is something which fascinates us, and we also take a very a reductionist approach in understanding how the systems work. We use light microscopy and electron microscopy and cell biology and biochemistry to understand normal physiological conditions and pathological conditions associated with the biological motility.
What aspects of your training as a PhD postdoc did you inherit into your current research problem? And how did you make it your own or adapt it or make it relevant to the present Indian context?
Okay, so that's a two-part question, I believe. So I can maybe split that into two. First is integrating my PhD and postdoc training. So in my PhD, I did X-ray crystallography and structural biology, and that actually helped me understand the problems in a more structural perspective. Then in my postdoc, I was involved in studying molecular motors and using microscopy and biophysics. So that is when I started understanding how I can use. That's when I got fascinated about biological motility, let's say, and combining these two was really what is happening in the lab. So we combine both structural elements, understanding the tiny molecular details. At the same time, we also take a very bird's eye view of the problem using microscopy and other cell biological approaches. So it has actually been a good platform for me to integrate both my PhD and postdoc training. Now, coming back to your question about how I have adapted or how it is relevant to the Indian context, this is actually the setting which has happened in the inStem, which is actually nurturing in that scenario. So our theme is cardiovascular biology and diseases, and in that we have a human geneticist who actually looks into how single point mutations are being causing cardiomyopathies in the Indian subcontinent families. And this is where I come in. So most often these genes are associated with biological motility. So we take those mutations and understand how they affect their property. Most often these are mutations which doesn't completely kill the subject or the process, but they slightly shift the balance towards one way or the other. And that is why it is a human disease, because otherwise the person wouldn't have been born. So we have to, if you want to understand how these single point mutations actually, because we have to use a variety of approaches, and that is again like the training from my PhD and postdoc actually combines that to understand that. So in a way, I think overall the both PhD and postdoc and also the setting here in STEM has actually created a unique program, I would say.
Minhaj, as an early career researcher, what are your roles and responsibilities? Do you still get to spend time at the bench?
Unfortunately, I don't spend that much time in the bench as I would like. But in the beginning, I used to spend quite a lot in the bench because as a new PI, I was the one who was responsible for training the people in the lab, the beginning, the first wave of people. And later on, I realized that at some point of time, the people whom I have trained, they are quite capable of training the next generation. So I took a step back. And my main role now is to supervising the students and understanding their problem, or finding new ways to solve their problems. That's what most of the time I spend. In our institution, there is no undergrad courses, so we have very limited number of opportunities to teach also. And but there is also a lot of academic committee roles which I'm also involved in. So in a typical day, there will be mostly about talking to the students, here and there few committee meetings, and there will be interesting talks. So that's what that's the main responsibility of an academic PI, I believe.
Minhaj, as someone who has completed a full circle from being mentored to being a mentor of young graduate students, can you describe your style of mentoring? How similar or different are you from your mentors?
So I don't know what is my style of mentoring. Maybe you should ask my students. But how different or similar to my mentors? There's obviously I would have imbibed certain characteristics from my mentors. And on one thing I would say is that, like, from my PhD, I worked with Professor Alfred Wittinghofer, and so he had a very big lab. I mean, he had a whole department which is under him, but somehow he managed his time very well, and he's a very good manager in talking to people and resolving conflicts, and also the work ethics were completely different. So, and that was a very new because I moved from India to Germany, and then it was a very new setup for me, and I learned quite a lot from there. In my postdoc, I was with Ron Whale, and the UCS of peer system and their culture is completely different. I mean, it was several notches up in terms of, I wouldn't say quality, but like there is a lot of peer pressure, I would say. But most of all, like I learned quite a lot from Ron also, because he, apart from being a fantastic scientist, we all know that like he has created so many new initiatives apart from doing science, which is beneficial for the whole of the community. So I have definitely learned quite a bit from both of them, and try to incorporate that in my own working style. But most often I have observed that like some of the best mentors are people who uh, they they find good people and they explain the problem. This is the problem, and if they are interested in the problem, you have to leave them alone. Rest of it falls apart, because no matter how much you try to push someone, you will not be able to achieve unless it inherently motivates them. So that's something is a key part of my mentoring style, I believe.
Minhaj, as an early career researcher, you certainly wear many hats. So is there a typical work day? If yes, what is it like?
Uh, there is no typical day, I believe, and every day is a different day. So most of the time, on a working day, I try to come early, so that like before the students arrive, I try to finish some of the emails and writing. And then when the students start to arrive, as I mentioned earlier also, that like most of the time I spend my time by talking to them and mentoring them. And I separate the days as blocks, so that they can understand that like I'm free during this time, and the students also have their experiments planned. So they usually have 1 hour, 1.5 hours downtime in certain processes. So I give them blocks saying that like, hey, I'm free in the morning block this time. If you want to meet, we can meet at that time. In this way, I think like we use our working day very efficiently, so that like I also would like to leave by 6 or 7, so that like I don't spend the whole evening also sitting in the lab. So this is something I have tried to consciously incorporate in my day, because during my PhD and postdoc days, we have actually worked quite unearthly hours, and I have made a conscious decision that like I would try to structure my day from 9 to 6, so that like I also have other things to do in my life.
Minhaj, what are the challenges of being an early career researcher in India today in the life sciences?
As it is like in any other country, it is also challenging to do research in India, and the challenges are somewhat unique, I feel. So for example, like we have certain timelines in our mind, and it doesn't match up, and this could be because of various reasons. It could be because your reagents or the parts of the equipment don't arrive in time, or something that happens in the lab which is beyond your control. So in such cases, I think it's wise to not take oneself too harsh, and take a step back and think about how to manage this expectation, but at the same time equally not compromising the quality of the research. That's a very unique challenge, I feel, in this country. The second challenge is how do you maintain international presence at the same time? You also don't want to compete with the Western counterparts, because as I mentioned, the timelines are completely different here. But at the same time, if you are isolated completely, you are not standing up with your peers, with whom you might have trained or worked alongside when you are training in the Western world. So there is a challenge in balancing that act. So how do you think about a local problem and how to stand with the international community is again a very unique challenge, I feel, in the Indian scientific context.
Minhaj, for someone who is looking to start a career in academic research in life sciences in India, what are the typical and atypical sources of funding that one can tap into?
The typical sources of research funding in this country are government funding bodies. This is your typical DST, DBT, and the India Alliance and ICMR or CSIR. For people who want to return back to the country, there are several attractive fellowships available. The Ramalinga Swamy from DBT, Ramanujam from DST, India Alliance has this intermediate award. So all these things are very, very lucrative and attractive for anyone who wants to come back to India. There are also few philanthropic initiatives have been initiated in this country, but which is untapped. I think it's a very nascent stages. We are trying to bring those funding also in the mainstream. Because if you look at the US situation, apart from your NIH and NSF or DoD sometimes, there is a lot of society which funding goes into research. For example, the American Heart Association or the Lymphoma Society. There are many examples like that. So we don't have such kind of societies which can also fund research in India. And this we call atypical, let's say, like non-traditional funding sources, which is a challenge and also equally an opportunity, I believe.
Minhaj, can you throw some light on the recent changes in the publishing landscape the world over and how it impacts the research life cycle today?
So I'm quite optimistic about the whole situation currently, although there are different arguments about how it has become very toxic and how it's usually people are looking into journal impact factors in hiring and promotions all. But the whole situation about preprints and even open access has made me think, look, it is actually in a positive direction. For example, I think if you want to finish a manuscript, you write the manuscript, and if you want to tell the community, you put it in a preprint server. And then the community knows that like you have a paper which is coming out from your lab, and it's just a matter of time that that particular piece of work will be peer reviewed and published in a journal. So as a researcher, I feel that like that's a way much more relaxing situation, that like I have finished this piece of work and it will eventually find its way to a peer reviewed journal at some point of time. And as a researcher, I can start thinking about new problems or finishing up other manuscripts rather than keeping it inside my computer and not talking about that to anyone. So I think that is a very positive scenario in the past few years, and I'm looking forward to take advantage of that situation.
Finally, Minhaj, are there any words of career wisdom that you would like to leave our listeners with today from your journey so far?
I think it is important to understand if you want to do research, I would strongly suggest that like one should give it a try. Let's say if you are an undergrad who's finishing up, give it a try doing a summer in the lab or a project thesis somewhere, or at least give one or 2 years working in a research lab before you want to commit for a PhD. Because often I see, or we see, that like people come into research and they have some picture in their mind which is not matching to their expectation. So, and also it's important to understand that like most of the undergrads who come into the system have actually passed or even aced all the exams. And that's how you get into the system, because there is no other way to judge you to bring into the system. But the first thing when you come to research lab, you will find that not everything works and there will be a lot of failures. And if you are not able to navigate through that failures, it is going to be a very tough thing. So that's something I would strongly recommend people to look into. And if you're not good at taking failures, I think research is not a good place to be in.
Thank you, Minhaj. It's been very inspiring for me to talk with you today, and thank you for sharing the valuable lessons from your career story. Thank you all for listening, and we hope that you found this both interesting and useful. To listen to more science professionals talk about their career journey, do subscribe to our episodes only on crafting your career in science. If you're passionate about scientific research, communication, outreach, and science education as we are, please connect and engage with us, and here are some ways that you can do so.
Visit our website at www.indiabioscience.org.
Subscribe to our newsletters.
Write for us and join our online discussion forum at discuss.indiabioscience.org.
Advertise jobs, grants and events in the life sciences on our website.
And feel free to contact us anytime at hello@indiabioscience.org.
Until next time, enjoy your science and stay engaged to enable change.